Hello everyone, this is Carla Tuting, a second year college student taking up a Bachelor of Secondary Education major in mathematics. Today I would like to share with you the contributions of Euclid to mathematics. Euclid was an ancient Greek mathematician, came from Alexandria, and known as the father of geometry. He is mainly known for his work in the field of geometry and gave many more theorems. And one of his theorems is that every positive integer greater than 1 can be written as prime numbers. And the other one is that there is an infinite number of prime numbers. His most famous work is the 13-volume set called Elements, which is the collection and combination of work on the important mathematical formulas to make learning more accessible. He divided the elements into 13 chapters each, called books. These elements contains a series of mathematical proofs, explanations of equations that will always be true, which become the foundation for Western Union. Euclid also was a scholar thinker and the most influential figures in the field of mathematics. His contribution to mathematics is to gather, compile, organize, and rework the mathematical concept of his predecessors into a consistent whole later to become known as Euclidean geometry. He also introduced the method of proving a geometrical result by deductive reasoning, based upon previously proved results and some self-evident specific assumptions called axioms geometry and postulates. So, in the history of mathematics, one of the highly esteemed work of all times was his Elements. It served as a prescribed from its publication till the 20th century. So the reasons why Euclid was influenced to mathematics is that his work is more than just explanations of geometry or even in mathematics. The way in which he used logic and demand proof for every theorem shaped the ideas of Western philosophers right up until the present day. Euclid has five general axioms, and these are number one, things which are equal to the same thing are equal to each other. Number two, if equals are added to equal the wholes or the sums are equal. Number three, if equals are subtracted from remainder or the differences are equal. Number four, things that coincide with one another are equal to one another. Number five, the whole is greater than the part. The 13 books of the elements of Euclid are: number 1, triangles, perpendicular, parallels, area of rectilinear figure. Number 2, transformation of area, geometric algebra. Number 3, circles, chord, and tangents. Number 4, polygons and circles, construction regular polygons including the regular pentagon. Number 5, treatment of proportion. Number 6, idea of proportion applied to similar figures. Number 7, theory of classifications of number as even, odd times, odd plane, solid perfect, and others. Number 8, study of continued proportion. Number 9, number theory including a proof that the number of prime is infinite. Number 10, study of irrationals. Number 11, solid geometry. Number 12, the method of exhaustion used to show that circles are proportional to the diameter. And the last one, the number 13, regular solids. Thank you. Euclid axioms. We connect two points in a straight line. We extend the line in both sides. Right angles triangles consist of 90 degrees. We can draw the circle from the center point. Euclid was a Greek mathematician best known for treatise on geometry, which is the elements. This influenced the development of Western mathematics for more than 2,000 years. Euclid's Elements contains 465 propositions, 93 problems, and 372 theorems. Euclid gave the proof of a fundamental theorem of arithmetic that every positive integer greater than 1 can be written as a prime number, or it is itself a prime number. For example, we have 35, so it is equals to 5 times 7. Another we have 64, which is 6 times 6. He was the first one to state that there are infinitely many prime numbers, which is also known as Euclid's theorem. He further elaborated this statement by saying that for any given finite set of primes, if you are going to multiply all of them together, then add 1, then a new prime has been added to the set. Suppose we have p is equals to 36, and 36 is equals to 2 times 3, which is 6 times 6 equals to 36. So we have 2 times 3 times 6. So we have 6 minus 1, which shows that there is a prime number 5, which was not there in the list of factors initially. It is a process which can be repeated infinitely. Euclid also observed some very interesting properties of perfect numbers. They are triangular numbers, so they are the sum of all consecutive numbers up to the largest prime factor. For example, we have 6. 6 is equals to 1 plus 2 plus 3. Another we have 28. So 28 is equals to 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 is equals to 28, and so on. Also, he gave the proof of the Pythagoras theorem. Although there were hundreds of proofs already in existence, his proof was exact and lucid. He used only those propositions and definitions that he had already proved to be true. He used geometry instead of algebra to derive this proof. Euclid also formulated the Euclidean algorithm, which states that the greatest common divisor, which is known as the GCD, of two integers a and b is the largest integer that divides both a and b. For example, so we have let a is equals to 36 and we have b is equals to 48. Then the greatest common divisor, or the GCD, is equals to 36 and 48. Is calculated as if a is not greater than 0 and b also is not greater than or equal to 0, then by long divisions method, we can write 48 is equals to 1 times 36 plus 12. Then we will calculate the GCD, which is the 36 and 12. As the GCD, we have 36 and 48. So we have the greatest common divisors, which is the 36 and 12, where a is equal to 36 and b is equal to 12. Then by the long division method, we can write 36 is equal to 12 times 3 plus 0. So the GCD 36 and 48 is equal to 3. We will stop this process when either a or b will become 0. If a is not equal to 0 and b is not equal to 0, then by long division method, we can write 48 is equal to 1 times 36 plus 12. Then we will calculate the GCD as 36 and 12 as the greatest common divisors 36 and 48 is equal to 36 and 12. While Euclid's life and identity remain a mystery, his work is a huge boon for modern education and our understanding of geometry and mathematics as a field. While Euclid may not be the most influential figure, his contributions have undoubtedly played an important role throughout human history. Thank you.